Think about everything you have ever touched, seen, or loved. Your morning cup of coffee, the smartphone in your hand, the person sitting next to you, and the actual air filling your lungs right now. According to the most successful, most tested, and most precise scientific theory in human history, none of that should be here. If the laws of physics as we understand them were followed to the letter during the birth of our cosmos, the universe should have winked out of existence less than a nanosecond after it began. We should be living in a universe that is completely, utterly empty, filled with nothing but fading light and lonely shadows. Physicists call this the greatest mystery in science, and it's not just a small mathematical error or a rounding mistake. It is a fundamental missing piece of reality that suggests we are essentially a cosmic accident that shouldn't have happened. Today, we are diving deep into the impossible heart of the Big Bang to find out why every physicist agrees the universe should not exist, and why the fact that you are even here to listen to this is a direct violation of the rules of the universe. To understand why our existence is a problem, we have to talk about the most perfect symmetry in nature, the relationship between matter and antimatter. In the early 20th century, Paul Dirac, one of the brilliant minds of quantum mechanics, realized something startling while working on his equations. He found that for every particle of matter, there must be a twin particle with the same mass but the opposite electrical charge. If you have a negatively charged electron, there must be a positively charged version called a positron. This wasn't just a neat trick on paper. We eventually proved it in the real world. We found that antimatter is real. It's not science fiction. We use it every day in hospitals for PET scans, and we create it in tiny amounts at places like CERN. But here is the catch. When matter and antimatter meet, they don't just bounce off each other. They annihilate. They turn into pure energy, specifically high-energy light. It is a perfect 100% efficient release of energy. Now, let's go back 13.8 billion years to the Big Bang. In that first incredible fraction of a second, the universe was a soup of pure energy. According to the standard model of particle physics, which is the Gus source code for how the universe works, energy must be converted into matter and antimatter in exactly equal amounts. It's a bit like a mathematical equation that must remain balanced. If the Big Bang created a billion particles of matter, it must have also created a billion particles of antimatter. No more, no less. But here's the problem. If there were equal amounts of both, they should have immediately found each other in that dense, hot early universe and annihilated. Every single particle of matter should have been canceled out by a particle of antimatter. The universe should have become a massive flash of light and then nothingness. There would be no stars, no planets, no atoms, and certainly no humans. And yet, look around you. The universe is clearly made almost entirely of matter. As far as we can tell, looking through our most powerful telescopes at the farthest reaches of space, there are no massive galaxies made of antimatter. If there were, we would see incredible bursts of light at the boundaries where they touched matter galaxies. The cosmos is overwhelmingly biased toward matter. This is what physicists call baryon asymmetry. It means that something happened in those first few moments that broke the perfect symmetry of the universe. For every billion particles of antimatter, there must have been 1,000,001 particles of matter. That tiny surplus, that 1 in a billion left over, is what eventually clumped together to form everything we see today. We are the debris of a near-perfect cosmic cancellation. This 1 in a billion error is the only reason we exist, but physicists have absolutely no idea what caused it. Why would nature, which seems to love symmetry so much, suddenly decide to favor one type of particle over the other? Some of the brightest minds at CERN are currently obsessed with this. They are literally trapping antimatter in magnetic bottles for weeks at a time, trying to find even the tiniest difference between it and regular matter. They measure its mass, its magnetic properties, and even how it reacts to gravity. In late 2023, they confirmed that antimatter falls down just like regular matter, which ruled out the idea that anti-gravity might be the answer. So far, antimatter looks like a perfect mirror image. And that's the problem. If it's perfect, the asymmetry shouldn't exist. Let's think about the technical difficulty of studying this. Antimatter is incredibly hard to handle. Because it annihilates the moment it touches regular matter, you can't just put it in a jar. If it touches the walls of the container, it's gone. Scientists have to use incredibly complex magnetic and electric fields to suspend these particles in a vacuum. It's like trying to hold a piece of hot coal in the air using only magnets. At CERN, They have an antimatter factory where they slow down these particles enough to study them. And even after decades of research, the standard model still insists that the universe should have canceled itself out. Physicists are looking for a crack in the mirror, a tiny flaw in the laws of physics that would explain why matter won the fight. One of the leading theories involves something called CP violation. This is a technical term for the idea that certain particles might behave slightly differently if you swap their charge and their spatial orientation. We have actually seen this happen in very rare cases with particles called kaons and B-mesons. We found that they don't treat their antimatter twins with perfect fairness. However, the amount of CP violation we've discovered so far is nowhere near enough to explain the massive amount of matter we see in the universe. It's like finding a penny when you need $1 billion to pay off a debt. The math just doesn't add up. Another fascinating possibility is that the answer lies with the most elusive particles in the universe, neutrinos. Neutrinos are often called ghost particles because they can fly through a light year of solid lead without hitting a single atom. Trillions of them are passing through your body right now as you listen to this. Some physicists think that neutrinos might be their own antiparticles. If this is true, it could lead to a process called leptogenesis, which might have tipped the scales in favor of matter during the early universe. There are massive experiments underground, like the Dune Project, currently trying to catch neutrinos in the act of changing their flavor to see if there's a secret bias hidden in their behavior. Then there is the concept of the antimatter universe. Some people wonder if maybe the symmetry wasn't broken at all. What if, during the Big Bang, the antimatter was just pushed in one direction and the matter in another? This would mean that somewhere out there, far beyond the observable universe, there are entire galaxies, stars, and maybe even people made entirely of antimatter. They would look exactly like us, but their atoms would have positive electrons and negative protons. However, most cosmologists find this unlikely. The early universe was so small and so hot that everything was mixed together. There was no separation of the ways. If matter and antimatter had separated later, we would still see the violent signature of their contact somewhere in the sky. This mystery goes deeper than just matter and antimatter. It touches on the very constants of nature. If the strength of gravity, the charge of an electron, or the mass of a proton were even slightly different, the universe would either have collapsed in on itself instantly or expanded so fast that stars could never form. Physicists call this the fine-tuning problem. It's as if there are a dozen different dials used to set up the universe, and every single one of them was turned to the exact, perfect position demanded by life. If you moved one dial by even a fraction of a millimeter, the whole thing would fall apart. This leads us to the multiverse theory. Some scientists argue that our universe shouldn't exist because the odds of it happening are so low. But if there are an infinite number of universes being born all the time, each with different settings, then eventually, by pure chance, you will get one that works. In this view, we are only here to ask the question because we happen to be in the lottery winner universe. It's not that the universe was designed for us. It's that we could only exist in a universe that happened to have these specific, improbable settings. It turns the impossible into a statistical inevitability. But even the multiverse doesn't satisfy every physicist. There is a desire in science to find a pure theory of everything, a single, beautiful equation that explains why things are the way they are without needing to rely on luck or a billion other universes. We are looking for the reason why the symmetry was broken. We are looking for the fundamental law that says matter must prevail. Until we find it, our understanding of the universe is like a book with the first and most important chapter ripped out. We know how the story ends, but we don't know how the main character survived the first page. Think about the scale of this error for a second. The entire observable universe, with its 2 trillion galaxies, is just the tiny leftover from this massive annihilation. We are the 3% of the original energy. The rest was turned into a ghostly background of photons that still fills the universe today. In a very real sense, the universe is a graveyard of antimatter. We are living among the ruins of a cosmic battle that took place in the first microsecond of time. This problem is so significant that it has forced physicists to question the nature of time itself. There is a theory called the CPT theorem, which says that if you reverse the charge, parity, and time of a particle, it must behave the same way. Some have speculated that if matter moves forward in time, antimatter might be moving backward in time. If that sounds crazy to you, you're in good company. It sounds crazy to many physicists too. But when the current laws of physics tell you that your existence is impossible, you have to start looking at the crazy ideas. Let's talk about the technical side of the Higgs field. The discovery of the Higgs boson in 2012 was a massive milestone. The Higgs field is what gives particles their mass. Some researchers believe the way the Higgs field switched on during the early universe might have contributed to the asymmetry. If the transition wasn't smooth, it could have created bubbles in space where matter had a slight advantage. This is what science is all about. Taking these high-level, abstract ideas and trying to find a physical mechanism that can be tested. But so far, the Higgs doesn't seem to have enough flavor to explain the sheer amount of matter we see. The fact that we are even here to discuss this is a testament to the resilience of X stuff. Nature tried its best to return to a state of pure light and perfect balance, but it failed. A tiny, messy, beautiful imperfection crawled out of the heat and the chaos. That imperfection became the hydrogen atoms that fueled the first stars. Those stars cooked heavier elements in their cores: carbon, oxygen, iron. When those stars ended their lives in spectacular explosions, they scattered that material across the void. Eventually, that stardust clumped together into a blue planet orbiting a yellow star, and billions of years later, that stardust became you. You are, quite literally, made of the error in the equations. When you think about your daily life, the stresses and the triumphs, remember that you are a survivor of a cosmic purge. You are part of the 0.1% of matter that managed to escape the Great Annihilation. This gives us a different perspective on the universe. Instead of a cold, indifferent space, it looks like a place of incredible, almost miraculous complexity. Every atom in your body represents a victory over the void. The fact that the universe shouldn't exist according to our theories doesn't mean the universe is wrong. It means our theories are incomplete. And that is the most exciting realization any science enthusiast can have. There are new experiments on the horizon that might finally crack this case. High-precision laser spectroscopy of antihydrogen is reaching levels of detail we never thought possible. We are looking for a difference in the 6th or 7th decimal place. We are also building more powerful particle colliders that will push the boundaries of the energy frontier. We are trying to recreate the conditions of the Big Bang with even more precision to see if we missed something. Science isn't finished. We are in the middle of a detective story where the victim is the vacuum and the suspect is the laws of physics themselves. In the world of computer knowledge and information theory, this asymmetry can be seen as a way of coding information into the universe. A perfectly symmetrical universe of light contains very little information. It's like a white screen. By breaking that symmetry, nature created bits, particles of matter, that could be arranged into complex structures. Our existence is the result of the universe's first data entry. We are the signal that emerged from the noise. It's also worth considering the philosophical implications. If the universe shouldn't exist, if we are truly a mathematical impossibility, does that change the way we value life? Does it mean that intelligence and consciousness are even more rare and precious than we suspected? If the settings of the universe had been off by a hair's breadth, there would be no one to witness the stars. The universe would be a dark, silent theater with no audience. Our being here provides the observation that quantum mechanics tells us is so important. We are the eyes of the universe looking back at itself, trying to understand how it got here. Every physicist you talk to will have a different favorite theory. Some like the idea of extra dimensions that siphoned off the antimatter. Others prefer the idea that our understanding of the early universe's expansion is fundamentally flawed. But they all agree on one thing: the standard model is not enough. We are standing on the edge of new physics. Just like Einstein's relativity expanded on Newton's laws, we are waiting for a new breakthrough that will finally explain why the mirror was broken. We are waiting for the equation that proves our existence isn't a mistake. Let's take a moment to appreciate the sheer persistence of matter. It survived the Big Bang. It survived the high-energy radiation of the early years. It survived the gravitational collapse of galaxies. And it survived the harsh environments of supernova explosions. It eventually found its way into a biological system capable of thinking about its own origin. This is the greatest story ever told. It's a story of survival against odds that are so high they can't even be properly visualized. It's a story of how a small, imperfect leftover became everything we know. As we look up at the night sky, we aren't just looking at light. We are looking at the survivors of the ultimate war. Every star you see, every galaxy you can imagine, is a monument to the moment matter won. The Great Annihilation left its mark on every corner of the sky. The cosmic microwave background radiation is the fossilized heat from that era, a permanent record of the trillions of annihilations that took place before the universe was even a second old. We are literally bathed in the echoes of a period where we were supposed to disappear. The search for the broken symmetry is a journey that teaches us humility. It shows us that even our best theories, which can predict the movement of stars with incredible precision, can still be fundamentally stumped by the most basic question of all. Why is there something rather than nothing? It keeps us curious. It keeps us building bigger machines, writing more complex code, and looking deeper into the dark. The impossibility of our existence isn't a reason to give up. It's a reason to dig deeper. It reminds us that there are still mysteries in the plain light of day, and that the universe still has secrets that it hasn't shared with us yet. So, the next time you feel small or insignificant, remember the baryon asymmetry. Remember that you are a 1 in a billion miracle. You are here because the laws of physics weren't followed perfectly. You are the product of a cosmic glitch. The universe shouldn't exist, and yet it does. And you shouldn't be here, and yet you are. That is the most profound and terrifyingly beautiful truth in all of science. We are the impossible outcome of an impossible beginning. We are the leftovers that learned how to dream. The struggle between matter and antimatter continues to be the ultimate frontier of physics. Whether the answer lies in the ghost-like neutrinos, the bubbles in the Higgs field, or a crack in the CP symmetry that we haven't found yet, the pursuit of this truth is what drives the human spirit. We want to know why. We want to understand the source code, and we won't stop until the math finally matches the reality of our existence. Until then, we live in the mystery. We inhabit the anomaly. We are the beautiful mistake of the cosmos. Thank you for exploring the edge of theoretical physics with us. The universe is a strange and wonderful place, and the more we learn, the weirder it gets. But that's what makes the journey worth it. In a universe where everything should be simple and empty, we found a way to be complex and full of life. That is a victory worth celebrating every single day. Keep looking at the stars, keep asking why, and never take your impossible existence for granted. You are a citizen of the survivor universe, and the stars are just the beginning of your story. Keep being curious, keep being impossible, and we will see you on the next deep dive into the mysteries of the void.